Welcome. In this lesson, a simple elevator system will be modeled. We will learn how to set up the model with its major components. The aim is to practice the modeling process. In this slide, let's have an overview of the elevator system. The counterweight and cabin are connecting by two lines. The system is operated by the mass, inertia, and also frictions. Capture and save this slide as a picture into the past, and we will import the picture into MSIM in order to give a clear overview during modeling. Launch MSIM and let's import the specification we just saved. Building the following simple system. Mechanical category will be used. From the 1D mechanical category, ropes components are used to model the elevator rope and sheave. Position the components onto the sketch, such as rope 4 and rope 4 and sheave 14. Mass and inertia components are also needed. Drag mass, friction, and stops to the counterweight and the cabin position respectively. Rotate them and connect with a zero force source. Drag and rotary load two ports to represent the properties of the sheave, connecting with zero torque source. Put a zero speed source on the top for a fixed boundary. Construct the line runs. Move to submodel mode. To manually select submodels, you can double-click on the components, which opens a dialog box with a list of suitable submodels. Double-click on the inertia and set the submodel to a rotate load. Double-click on the sheave and set the submodel to an ideal sheave. Double-click on the rope 2 and set the submodel to a longitude rope. Double-click on the two masses and set the submodel to 1D translation masses. Double-click on the zero force source and set to a zero force source. Move to parameter mode. Set the parameters according to the specification. Click on the inertia icon. Select yes to set use friction available. Expand the friction item and set the value of coefficient of viscous friction to 2. The default value of inertia here is the same with our specification, so we don't need to change it. Click on the sheave and the diameter of the sheave is 0.5 meter. Click on rope 1 and rope 2. Set the value of stiffness, viscous friction, and length of the rope, respectively. Click on the counterweight mass. Because of the initial position of the mass is at 4 meter position, so we set displacement at port 1 to 4. Select yes to set use friction available, and input viscous friction to 10 Newton per meter per second. Select ideal and stop type, and give the limitation of displacement to 0 meter to 4 meter. Then change the mass value to 70 kg. Take the gravity into account with setting -90 degree inclination. Do the same processing to the cabin mass, but with different values. Initial position is 0 meter. Viscous friction is 10 Nm per second. The limitation of the displacement is also 0 meter to 4 meter. The mass is 50 kg considering the gravity. Move to simulation mode and finish the compilation. By now, the application model is successfully built.